Hello everybody! In this video I'm gonna show you the main commands of Git, or at least the ones I expect you to use 99% of the times in your project. This is going to be very similar to what I have done in the lecture. Okay, so just a short version, easier for you to follow. So then here I have our Python skeleton, or a very similar version, and I'm gonna just simulate some developers doing some changes. Okay? For this version, I already made the first clone. So you had in your Git instructions how to clone the project for the first time. So you have this GitLab set up for you. You basically copied one of those URLs and then you did git clone. Yeah? Or actually you did via PyCharm, right? Import from URL or something and then you got the project. So that's what I have right now. And let's suppose I'm developer number 1 and I get here and I decide to add the name of the course as part of the functionality I'm building. So I'm gonna say this is TI3115TU, and I'm happy with this change. Of course, in real life you're gonna do bigger changes, but let's say I'm happy. Let me now save this in my Git repository. So how do we do this? I will open my terminal. Of course, you feel free to use PyCharm's terminal as I'm gonna do here. If you're using your terminal that is provided by your OS, that's also fine. If you want to use the Git functionalities later on that PyCharm offers you, and it's more UI friendly, why not? Feel free to use it. But here I'm going to use the terminal so that you can really see the inner workings of Git. So I made a change. The first command that I want you to know is git status, and it basically shows you basically all the files we have in the project and the ones that Git noticed a change. And you see Git is pretty smart. So we have all those files here and Git knows that the factorial calc is the only one that we changed so far. We are happy with this change and I'm gonna store it. So there are 2 steps to do this. The first one is to first tell Git that the change in this file is something you want to store right now. And I do this using git add. Git add and then the name of the file. Project and then factorial calc, right? So the full path of the file. And if you notice the way I did this in the terminal, just to make our lives easier, right? So the terminal has those auto-completion features. So I basically typed the beginning of the word, so project, it's the name of the folder, right? And I press tab and it completes for me. And then fac and then tab and it completes to me again. So I typed the first 3 letters of the word. It could be 1, it could be 2, right? It really depends on the files that you have in there, right? So if you type the first letter, but then there are like 3 or 4 files with the first letter, the terminal won't really know how to complete. So if you're quite unambiguous, then the terminal, once you hit tab, it will complete for you. So that's what I'm gonna do. In practice, if you have many files, you can just type them all here, so you can put many files in a row. And then let me do git status again, and you see basically the same thing, but now it's green, right? It was red before, and now it's green. So it basically says, I know this file was changed, and now I know you want to record this change. You want to save this change. If you had more files in here, you would see more files, right? The ones you selected via git add in green, the ones you didn't select in red. And now it's time for us to save this change in something we call a commit. So imagine a commit as if, the time that you decided to add a version, you put all those changes in a box and you give this box a name. Okay, we call this box a commit. So that's what I'm gonna do, git commit. And this git commit needs one parameter, which is the message. So I will indicate the message using my -m, m as in message, and then between quotes the message for this commit. So let's say add the name of the course in the banner. Once I hit enter, Git says it repeats the commit message. It gives some information about the number of files changed, number of lines that were inserted, maybe number of lines that were deleted. In this case it was 0, so it doesn't show. And then it is done. If we do git log, I can see this new commit here. So this commit that has this hash, so kind of this unique number that represents this change, it is there. So let me quit this git log, and for that I just press Q, right, as in quit. So if I press Q, I'm out. But notice that this change is in my machine, so let the name of the course in the banner, but it is not in our server, right? So if I refresh the page, I will still see the last change that I have done before, which was this cleaning up before we started this demo, okay? If I do git log, you can actually see the current one, add the name of the course, and then the next one, which is cleaning up to start the demo. So the server is still here, and our local machine is like one step ahead. That is one of the beauties of Git, right? That you can do those changes and you can store those changes in your machine, and then later you can push it or send it to the server. How do you do this? Through git push origin master. So once I hit git push origin master, if everything goes well, you're going to see a message that looks like this. Something that it doesn't really make a lot of sense for us right now. Then the server, and then that everything was pushed from master to master. What does origin and master mean? So very quickly, origin basically means where you want to push this. We want to push this to the server, and when we did the clone for the first time, Git stored internally that origin points to our GitLab. So we're basically saying push to GitLab, to TU Delft GitLab, and then master is the name of the branch. So we're not going to really discuss this in this course, but you can have multiple lines of development. So imagine many teams working on the same software, and each one of them want to have their own particular line for a while before they merge into the main line of work. The name of the main line of work is called master, and that's what we're saying. So we are pushing to the main line of work. Just a quick remark, as I said in the lecture, so in computer science we are trying to rename terms that are not maybe the best, and because this master term sometimes can refer us to a master and slave type of analogy, you can see Git developers or Git users running away from this. So in the future you will see people renaming this to main, for example, instead of master. But historically this is how Git used to call the main line of development. So this is what we do. We want to push to our GitLab, which is called origin, and then to the main line of work, which is called master. Okay? And I can keep doing this. So let me, for example, add, let me just refresh to show that now we have this in the server. Yeah, so let the name of the course in the banner, it is there. And I can keep doing this. So let's suppose I want to make 2 lines of stars instead of just 1, right? That's the new implementation. And I'll do the same. So I can do git status. By the way, I can also do git diff, and it's going to show the difference of the stored code and the changes that I have just made. And if I do down arrow, you can see, in green the lines that I added. If I deleted some stuff, it would appear in red, these kind of things. Yeah, Q again to quit. So git status, it shows me the same file. Now what I have to do, again, git add, right? And then git commit. I'll do this the way I usually do, which is git add and then minus big A, which basically says to get all the files, right? It's very common that you're going to change more than one file, and it can be pretty boring to say file 1, file 2, file 3. So -A gets all the changes and puts them in the list of things to commit. And then git commit -M, double star lines in the banner. Great. Then I can do git push again origin and master. It is going to send all the information to the server. If I refresh, I see it right here. That's easy, right? One person working, you rarely have problems. But in real life, we have more than one developer. In your case, you have 5 or 6 people working on the same project. So you can imagine that we have many computers many developers working on the same code base, right? So then problems happen, and that's what we're going to simulate here. So what I'm going to do is I'm going to simulate developer number 2, and developer number 2 actually uses the terminal. Yeah, so let's differentiate this way. So if I'm here, it's developer number 2, and developer number 2 also doesn't use PyCharm. The person uses Sublime. So the person just joined the project. First thing that the person does is to clone. So git clone and then the URL, and then I have here. Let me increase the font, maybe it gets better. What we have here is just a folder with the Git repo. If I do git log, I see basically everything that there was in the server at the moment I cloned. Yeah, so double star lines is the last commit. Now let me open this in Sublime as well. Where did I put this? I guess desktop, demo, yeah, right here. Yeah. So we have the same thing here, okay? Now let's suppose the two developers are working at the same time, and this developer number 2, decided to add one more line of banner. Yeah, I'm doing simple features here just to illustrate Git, okay, folks? You're gonna do more complicated stuff, of course. And this person then does the same, git status, git add big A, then 3 lines of banner, okay? Great. But note that I'm not going to do git push right now. So this person has a repository that, you know, double star lines, and then the next thing was 3 lines of banner. Great. The other developer number 1, which is also changing source code, and then in here you see you don't see the 3 lines because this 3 lines is only on developers 2's machine, not in yours. You decided to add one more line here, which is kind of the year, the edition of this course, which is 2021. And this person also decided to then commit. So let's give a message, for example, year of the course. Great. So now notice something. For developer 1, the repo goes double star lines and then year of the course, right? This is what I have in developer 1's machine. For developer 2, I have double star lines and then 3 lines of banner. So notice that at some point, developer 1 and developer 2 went on different ways. Yeah, and both are stored in their local Git repos. But now it is time to send this to the server, right? So let's suppose developer 2 did it first. So git push origin master. Git, well, receives this change, right? This is just a normal change. If I go to the server now has basically what developer 2 has done. Then let's suppose developer 1 also comes here and then does git push. Notice that it doesn't work now. So Git rejected. And if we read the hint, so the updates were rejected because the remote, so origin, our GitLab server, contains work that you do not have locally. This is usually caused by another repository or another user pushing to the same GitLab. You may want to first integrate the remote changes before pushing again. So what goes on is you try to push something and then GitLab or Git in our server notice that, well, there's a difference here. I have this commit that doesn't exist in this developer 1. And I cannot simply receive this new repo or this new commit because where do I put it? Do I put it after what I have? Before what I have? Git doesn't really know how to solve this. So then it rejects and it says, well, human, you are smarter than I am and you can solve this for me. So that's what you need to do. So we cannot push. We need to first pull what is in there in the server and then solve any eventual problems first. So I'm going to do git pull origin master. So I'm going to pull things from the server first. We're getting the information and Git gets it. And then if everything goes well, and I'm going to explain what goes well means, Git gives this to us. So this is a very strange message, but basically it says, well, developer 2 had something, you had something, we had to combine them in one thing. And I do this in a new commit, so everything in Git is based on commits, right? And you have to just give a message to this new commit. And usually the message is something like, we're merging blah, blah, blah. I'm usually fine with this merge message. We just have to save, and to save, we have to, if you're in PyCharm's terminal, you have to press escape button, then colon, W as in write, and Q as in quit. Yeah, so this is a bit ugly, but that's how it works. If you're a Linux user, you're kind of used to it. If you're not, then, well, this is what you basically need to know, okay? Then you quit. Everything looks nice. It says merge made by recursive strategy. Doesn't really matter to us. But what I'm going to do now here is to do git k. Git k is just this interface that we can see what's going on. And if you pay attention to here, you see that, you know, when I said that developer 1 and developer 2 went different ways? So you can see this here. So double star was like the latest commit they had in common. Then one developer went this way, the other one this way. So we have these two branches, as we call. And then they got together again in this merge branch that we just created, and actually Git created for us. Great, right? So then you can see, you know, going sideways and then get together again, and this perfectly represents what I want to say. Oops, I closed it. Let me open again. So now that we solved the merge locally, we can actually push, because now Git will understand that, you know, what is in the server is a bit different from what is in here, but here it has just more stuff. And there were merges, but then the human solved the merge, so we're fine. If we refresh this here, we now see the merge also here. Perfect. For developer 2, of course, and that's what I expect you to do all the time, so those things happen, right? The developer pushes to the server, you have to get this back. You just do git pull to bring things, and everything works because, you know, there are no big changes. Git sees that developer tool is just a bit behind from what we have in the server, so it just brings the information. And perfect. So we discussed Git status, Git diff, Git clone, Git push, Git pull. Last thing I'm going to show in this video is how to solve a merge. Because in the previous version, Git was able to solve the merge. So if I look here, once Git saw the changes from developer 1 and the changes from developer 2, it knew how to merge, right? The 3 banners here and then the addition. This was not a big deal. But what happens if the developer changes the same line? So let's do this. So I'm going to change, this is developer 1, yeah? And I'm going to commit developer 1. And let's suppose developer 2 changed the precise same line. So developer 2, okay? So I'm going to, again, commit things, dev2. Now we have the same issue, you know, the same branch happening. At some point, developer 2 went one way, so you can see dev2 here, right? The merge and then dev2. And developer 1 went another way. So you see the merge and then the commit dev1. Now, let's suppose developer 2 also pushes first. It is going to work, right? Whoever goes first always gets it. And developer 1, if this person tries to push, Git will complain again. We have to do a pull. And now notice that Git didn't ask us to give the commit message. Why was that? Because there was a merge issue. The same line was changed by 2 developers. Which one should Git get? Git doesn't know, so it gives you as a human to solve it. So if I click, then PyCharm refreshes, and then Git shows to me basically the 2 versions. Right? I have this version that says dev1, I have this version that says dev2, I have this ugly notation here to show it to you in the file, and now it's up to you to solve. And what we need to do is to just make it to become a Python program again. So what I'm going to do is I'm going to just, you know, keep this line and say dev1 and dev2. So just remove the ugly stuff that Git puts and make your program to work again. Once you do it, all you need to do is to just store commit again, okay? Because we are right now in this merge state. So Git knows that the next commit is focused on kind of solving the merge. So that's what I'm going to do. Solving merge, let's say dev1 and 2. Yeah. Git log. We see the solving merge. Git k. we see again the same thing. Developer 1 went one way, developer 2 another way, and then we just merged them. If I now push, Git now receives, doesn't complain, right? Because the merge was solved. Perfect. Developer 2 can now pull without lots of trouble, because yeah, Git knows how to get the commit and the merge together. Okay, so this is basically what I wanted to show you: Git status, Git commit, Git add, Git push, Git pull, and how to solve a merge. This is just an introduction video to Git. There are lots of other things to do. Feel free to explore, and always call our TAs if you have any questions. Okay, have fun.